Welcome to Side of Science.
With Stacey and Ant, because every story has a side of science.
On today's episode, we're talking about terraforming Mars. Hi, Ant.
Hey, Stace, what's up?
Not much. You?
I don't know, doing a podcast.
Oh, what about?
Well, here's the question. Do you want to live on Mars?
Do I want to live on Mars? No.
Why not?
I've heard bad things, all the reviews.
Well, Mars is big, and I was researching a lesson on a mission to Mars, and it got me looking into why does everyone want to go to Mars? Sorry to burst everyone's bubble, but Mars sucks.
Does it?
It sucks. It's terrible. The only way it would even be remotely enjoyable to go live on Mars is if we terraformed it. So,
Terraformed it.
Terraformed. We're talking planetary engineering today.
Oh.
What would it take to make Mars livable in the same way Earth is?
Great. I'm excited.
Okay, so let's start. The conditions on Mars.
Conditions, yep.
There's no liquid water.
Yes. Ice only.
There's
Ice.
There's ice, baby. Yep. The soil is called regolith, so it's just a loose dust. It's not real soil. You can't grow anything in it. There's no nutrients. There's no nitrogen-fixing bacteria, and it contains something called calcium perchlorate, which basically means the soil is poisonous. The soil can't grow anything, and it'll kill us and plants.
It'll kill us how?
It's got these things called calcium perchlorates. So basically, chlorinated calcium at high enough levels that it ain't good for us.
So if we grew something in it, it would leach into the plants, or they would pick it up, and then the plants
would die.
Right. Okay.
So on Earth, we have these little microbes called dichlorominas and azospirers, which basically break down perchlorates in our soil into harmless products. Mm-hmm. They don't exist on Mars because there's no life on Mars.
I see.
No liquid water, poisonous soil. Daytime temperatures average around -20 to -30, and it goes down to about -120 at night.
And is this seasonal or is this all year round?
They have seasons like we do here. Their seasons last about 1.5 times longer than ours because they're a bit further out from the sun, so they receive a lot less sunlight. In winter, it gets really cold. In summer, you might be lucky to get a 20-degree day.
Oh, so it's like Scotland.
Basically. Okay. Poisonous soil, no water.
Well, no, the soil's all right, I think, yeah.
So it's really cold there. Mm-hmm. Gravity is 38% of that on Earth because it's further out. Oh, no, because it's further out. Listen to me. Because it doesn't have a molten iron core and it's smaller than Earth.
So it has less mass.
It has less mass.
So less gravity.
And less gravity.
So I would weigh less on Mars.
You would weigh less.
Oh, well, I'm going.
Okay, so we'll put that in the positive column. Weight loss, tick. But because it has no molten iron core, it also doesn't have a magnetic field around it. Now, Earth has a magnetosphere, which protects us from a lot of the sun's radiation and solar wind. Mm-hmm. So your UV index on Mars, through the roof.
Oh, so you get a good tan.
Oh, you're getting tanned all right. You're getting a cancerous tan real quick.
Yeah.
So there's a constant stream of charged particles, mainly electrons and protons, just bombarding the planet.
From the sun?
From the sun.
Okay.
It ain't good. It has a thin atmosphere. So Earth, we got a nice atmosphere. Air, mainly nitrogen. Mm-hmm. Got some oxygen in there. Throw some carbon dioxide and a bit of other things. On Mars, 90-something% carbon dioxide.
Right.
And that's because it has no magnetosphere. So those particles from the sun stripped away all the nitrogen and all the lighter gases from the atmosphere. We can't breathe.
Is the other 10% oxygen, or we don't have an oxygen cycle?
It's about 96% carbon dioxide, and the rest is a little bit of nitrogen, a little bit of argon, and like 0.0145% oxygen.
Oh, right. So we're going to need like respirators.
You ain't breathing.
Yeah.
No. And the last thing, we've got this beautiful atmosphere, which means we have atmospheric pressure on Earth. And our bodies have evolved to deal with that. Mm-hmm. On Mars, there's no atmosphere, so there's no atmospheric pressure. So you're basically living in a vacuum.
So you're not getting weather? Is that what you're...
You're not getting weather.
Yep.
It's sunny every day, so we'll put that in the positive list. Yeah. But it is, because there's no atmosphere, it is also prone to these massive dust storms that can last weeks. Ah. So you're going to get sun, you're going to get radiation, and then occasionally you might get a big dust storm.
Okay. Yeah, so I still don't want to go.
No, it's not good. You can't live there unless you're seriously got a lot of equipment to keep you going.
So why is this a thing in terms of people investing and looking at actually going to Mars?
So I was wondering that myself. And a lot of it is science is a human endeavor. Okay, so we went to the moon.
Yep.
We didn't have to go to the moon, but on our mission to the moon, we invented so many different technologies, computers, Velcro, all sorts of things came from our endeavor to go to the moon and all the technological advances that went with it. And I think it comes back to that human nature thing of how did life start on Earth? Let's learn more about how we came to be. Could it have started on other planets?
Okay, so if we go there, we'll then learn more about how to be better at.
I think that's the idea. Mars has always fascinated people. It's always Mars. I don't.
Yeah, why not Venus?
Well, we'll get to Venus later. Venus has its own part to play.
Okay.
Venus is hot. Maybe people like the cold weather more. But Mars used to have a thick atmosphere, they think. They think Mars had a thick atmosphere and it used to have running water. Oh. And so this all hints at maybe, just maybe, it had life.
Okay.
So if we were to boil it down, I'd say that a lot of it comes down to, is there life beyond Earth? Well, Mars is the closest thing that might have it. Let's go check it out.
What do they think happened to the atmosphere?
Well, at some point, they think it had a molten iron core, which gave it a magnetosphere, which protected the atmosphere.
Yep.
And because Mars is about half the size of Earth, they reckon the molten iron core cooled, stopped being molten, magnetosphere disappears, then the solar wind strips the atmosphere, and if potentially there were little green men there, they would have all died, along with the atmosphere and everything else.
Why does the molten core need to be liquid for it to have a magnetosphere?
We're getting technical here.
Because technically then it's still there, it's just a solid.
Correct. The reason planets need a molten iron core is something called the geodynamo effect. Essentially, your liquid metal moves due to temperature differences, like convection.
Yep.
And that creates an electric current, and any kid that's studying year 11 or 12 physics will know that electric currents create a magnetic field. So that's where your magnetosphere comes from.
Okay, so because it's a solid, there's no current, so you're not getting
There's
the
no
movement.
electric current, so there's no magnetic field.
Okay, thank you. Okay, so the conditions on Mars so far.
Yep.
We've got radiation.
Yep.
We've got no atmosphere.
No atmosphere.
We have windstorms.
Big
potentially.
dust storms.
Lots of dust storms. The soil's terrible. Nothing will grow in that.
Poisonous.
And we have
no liquid water.
Yeah, no water. So there's really, what are the reasons to go?
Well,
Not
you've
many.
got to be seriously dedicated. Old mate Elon Musk says he wants to die there. I still haven't worked it out.
It won't be hard.
No, it won't.
If he gets there, it won't take long. How long feasibly would you live? You walk out of your space rocket and...
Well, this is another thing. Like, and many sci-fi movies have depicted this. What happens to a human body when it gets sucked into outer space, into a vacuum, which Mars essentially is? Some movies say you'll freeze instantly because Mars is incredibly cold.
Yep.
But the human body, as you know, is actually quite good at maintaining its internal temperature. Mm-hmm. So you've got a couple minutes of your body going, okay, I'm cold, but we can keep the main organs warm.
Yep.
Some people think that your eyes will explode due to the vacuum because your body has internal liquids that are under pressure at normal atmospheric pressure, and once you go into a vacuum, they'll try to escape.
Yep.
That will happen at a slower rate. Kind of what actually happens, and there was the best evidence we have was in 1965 when they were training to go to the moon. In a big vacuum chamber, there was a leak in an astronaut's spacesuit. And so his internal pressure actually dropped to essentially a vacuum. No oxygen. You can last a couple minutes of that oxygen. But what happens is something called, they call it the Armstrong limit. Now,
After Neil?
I don't know. Oh. Maybe we should find that out.
Sorry.
But if you go high enough into our atmosphere, you lose pressure. And so pilots experienced this long time ago. The Armstrong limit is the altitude above which the atmospheric pressure is so low that water in your body starts to boil.
Oh, wow. Oh, that's... Oh, okay.
Yeah. So as you decrease...
Your body's 70% water,
Your
roughly,
body is 70% water.
and it then boils.
You will start boiling. So
That sounds painful.
It is. I'm sure it is. I don't know. I haven't asked the man, but we could maybe try and get him on. The last thing he remembers before he blacked out, and he was conscious for about 15 seconds, the last thing he remembers feeling was the water on his tongue start to boil.
Oh.
And he blacked out, and then they repressurized the chamber, and he survived, and he was all okay. But essentially, if you decrease pressure, your boiling temperature for water will come down, and it will come down so low in a vacuum that the water inside your body will start boiling. So your eyes will start boiling, your tongue will start boiling, you can't breathe, you're freezing, and on top of that, you're getting sunburnt by the radiation.
That's horrific.
So don't go to Mars.
I'm not going. But if you did go,
Yeah.
then you're going to have some pretty cool outfits to survive all this.
Yeah. Let's hypothetically say we're going to Mars.
Because they're selling tickets, aren't they?
I don't know who's buying them.
Can't you buy tickets to Mars?
Listen, I'm sure they're selling the Brooklyn Bridge again from what I've heard. But I don't know who's buying these tickets. But the amount of equipment we would need to send on a rocket to Mars is astronomical.
Good pun.
When you're first arriving, the first thing we need life support.
Yeah.
We need air, we need liquid water, we need to keep ourselves warm from negative 125 degrees. We need to constantly be in a spacesuit wherever we go because it has no atmosphere, and we need to be pressurized inside the spacesuit too. Otherwise, our eyes will boil.
The minute you take it off, you're in trouble.
You
So
did.
you've got to wear it for life.
Yeah, and you can't be falling over on a rock and getting cut in a hole.
Toileting.
Well, that's the other thing. You need to recycle all your waste.
I guess that's one way to get nitrogen.
Well, that is one way to get nitrogen, and one of the things we'll need if we want to terraform Mars is a whole lot of nitrogen. Don't know how much waste that involves, but in order to get waste initially, you need to get food. They think the best way they could do it initially, you can take air with you. They would have to take some sort of form of... They could use electrolysis to split CO2 to get oxygen.
Okay.
So we've got O2 covered.
Okay.
To use electrolysis, we need electricity. The good thing about Mars is that solar panels work really well there.
Oh, yeah.
There's no atmosphere.
Yep.
Unless there's a dust storm for 2 weeks.
You're out there with a broom then. Bring a broom.
Bring a broom.
Okay.
Liquid water, let's just say hypothetically we set up base near the poles. We could drill for ice and melt it into water, and we'd have to purify it or something, but it can be done. We're still talking in the realms of doable here.
Quick question, I hope. Why does the water, so we're in a vacuum on
Yep.
Mars, the water on Mars is ice, but if I'm not in a spacesuit, the water inside of me will boil?
So human bodies are really good at keeping us at what temperature?
37.
37. Once you drop the pressure down to a vacuum, water will boil at just below 37 degrees. So we're warm enough to boil that water.
Right.
But if the water escaped our body, or if we went out into Mars and I lay down for long enough and died,
It would
all the
freeze.
water would eventually freeze.
Okay, so it's happening pretty quick then.
It's pretty quick.
Yeah.
Like Mars is cold enough to keep the water as ice, but our bodies are pretty good at maintaining temperature long enough to boil the water in our tongue and eyes.
You keep going to songs like there was cold as ice there was drop the pressure. All right, sorry.
Showing your age these days.
It's just how cool I am.
So we can do a lot of these things. We can set up base on Mars. This is not out of the realms of doability. We'd most likely build some
You
underground
like a
bunkers.
challenge, don't you?
Well,
All right. Yeah.
not me. Other people. Everyone keeps talking about it.
Yeah.
NASA's planning missions. SpaceX is planning missions. People are buying tickets. I wanted to find out why, because it sounds terrible.
Yeah.
But we could build partial bunkers underground to protect us from the radiation. We got solar panels. We could grow food with hydroponics and aquaponics, potentially, because the soil doesn't do anything. We've got enough to set up at least a base on Mars for a few people to live. Maybe Uncle Elon and the rest of the billionaires who want to go there.
Technically, but how long does it take to get there?
9 months. And that's the quickest we could possibly get there.
And how much oxygen? Because if you get there, you're not coming back.
No, getting there is its own trouble in itself. To get there, you would need to carry an incredible amount of fuel. And there's a few ways they've thought about getting around that. They could potentially launch up multiple rockets into Earth orbit and then assemble a big rocket there. Or you can send up a rocket, refuel it in Earth orbit, and then send it across. One of the other things they're thinking about is potentially using methane as a fuel, and then you could get methane from Mars. But chances are you're not coming back.
No.
It's a one-way ticket.
And yeah, okay, because there's the fuel, but there's also all the oxygen you would need and all the supplies.
There's a whole lot of stuff.
Okay, so we're there though.
We're there.
Now what?
Well, now we're going to try and terraform.
What does it take to terraform Mars?
Well, if you haven't got it yet, the first thing we need is we need to give it an atmosphere and we need to heat it up.
Oh, I know how to do that.
Oh, let's hear it.
Burn the fossil fuels.
What fossil fuels?
Well, there wouldn't be any on Mars, but that's what we've done here.
That's essentially what we need to do. We need a greenhouse effect. We need to kickstart it, but we need it on steroids.
So we need global warming.
Oh, we need it.
We're masters of this.
We need an industrial revolution. We need kids in mines. We need every Ford Ranger Raptor and every one of those Dodge Rams on there just running their engines 24/7. The good thing is, creating an atmosphere and warming up the planet go hand in hand, as in everybody here should know from the greenhouse effect.
Yep.
And the first step is already there because we have CO2 on Mars in 96% of the atmosphere. If we can get more CO2 or more greenhouse gases up there, we can start warming the planet up. And you get a kind of a positive feedback loop. The more you warm the planet up, the more ice in the soil will melt, and that will release more CO2, which will then keep heating the planet up.
Yep. It's like a blanket.
Yeah, you start creating a blanket. The problem is we can't just have an atmosphere of CO2.
No.
We
don't have fossil fuels on Mars.
No,
because
there's never been anything living on there that we know of, unless there are little green men in the ground really deep that we can use that turned into coal sometime. But we need nitrogen. We need nitrogen and oxygen there. Some scientists suggest we import ammonia or methane, which will then naturally break down in the atmosphere into nitrogen and hydrogen.
Naturally?
Or naturally due to the radiation and everything from the sun.
Because on Earth, nitrogen, it's fixed by plants, or actually it's fixed by rhizobium, which is a bacteria that lives in
soil.
Leguminous plants and in soils to fix it.
So our legumes fix nitrogen into the soil, which is how we grow things.
Yeah.
We don't have any of those on Mars.
No, but you're saying the radiation will.
The radiation will break down the methane and the ammonia in the atmosphere into nitrogen.
But what if you have the global warming effect and you've got less radiation?
Well, that's a good thing.
Will you still get your nitrogen?
Well, the simple answer is no. The simple answer is we can't get enough nitrogen. We need to import it.
Okay.
So this is step number one. Your terraforming enthusiasts then suggest we go to one of the moons of, I think, Jupiter, Titan, and we start importing nitrogen. As you do. Okay. You just start traveling to other
trade deals.
Yeah, exactly.
Why not? Yeah. Set it up.
Or
I'll make a few phone calls.
Another suggestion is after we're done terraforming Venus, there'll be a whole heap of nitrogen left over we can then ship over.
Oh, Venus is first.
Yeah, just, really easy steps like that are the first step to terraforming Mars.
Why do you need nitrogen?
Because if we want to live on Mars the same way we live here, nitrogen makes up the majority of air, and we need nitrogen in our air so we can get those nitrogen-fixing bacteria to bring that nitrogen into the soil so we can grow things.
The plants need it for growth.
The plants need it, and we're used to breathing air. So we want air.
We need oxygen.
So
we need the plants
to
photosynthesize to produce the oxygen, so we need to feed the plants the nitrogen.
Ooh. We're talking about our nitrogen cycles here.
Yeah.
And that's what it comes down to. The first cycle we need to set up is our carbon cycle with the greenhouse effect.
Yep.
We need to set up our nitrogen cycle, and we need to set up our water cycle.
Massive, yep.
These are all really simple things to do, right? So
it is. So, well, it's not. It's not easy. That's a lie. It sounds easy. But you're going to have to fix the soil before the plants.
Well, this all kind of comes hand in hand. So the first thing we need to do is we need to heat up the planet enough to get liquid water. Life cannot exist without liquid water. Yep. That is one of the preconditions to have life on any planet is liquid water. So another way that scientists have actually suggested heating up the planet is to use those things we banned in the 90s called CFCs or PFCs.
Yep.
Now, they're an artificial greenhouse, which is about 1,000 times more effective than our natural greenhouse gases. So we could potentially set up, in our industrial revolution, when we got kids in the mines, we could set up an industrial scale CFC production facility there and just start pumping them.
It's a lot of aerosols.
It's a lot of people spraying Glen 20 into the air, right? Or another cooler way is we could just send rockets full of them and start crashing them onto the surface.
Oh, that's fun. Let's do that.
Before we get there.
Yeah.
So, okay, let's just assume we've got an atmosphere there.
All right.
We've warmed it up enough. We've managed to import nitrogen from another planet. We've got liquid water. The next thing we need, as you said, is something to start producing oxygen for us.
Yep.
And the first things they reckon are cyanobacteria, which most people would know as blue-green algae.
Yep.
So in our lovely, pristine rivers and lakes that we now have flowing on Mars, we just start pumping blue-green algae, which start photosynthesizing and producing oxygen into the air.
If there's ice there and then there was water there before, previously, is it possible that there are actually dormant bacteria or cyanobacteria on Mars?
Well, I think this is one of the reasons we've been trying to get there, to work this out. We've sent rovers there and it's been collecting samples and the search for life on Mars continues. But if we found them, that
would solve a problem.
Yeah, it'd be groundbreaking if we could dig up old, ancient blue-green algae on a different planet. But essentially, blue-green algae in all the rivers and lakes, we start getting oxygen.
Nice.
We think. From then, we could maybe move on to lichens and mosses, and they will again start producing more oxygen, but they will also start breaking down rocks and putting nitrogen back in the soil to hopefully get something of usable soil.
Okay, so they release kind of acids to break down rocks to start soil formation.
Yeah, and they stabilize the soil, add organic material. As they die, they'll start... So we're turning this loose dust...
You're getting a carbon cycle.
Yeah, we're kickstarting our carbon cycle now and our nitrogen cycle. Hopefully, after that, we can start introducing the nitrogen-fixing bacteria. We can move on to bigger plants. And if we've managed to do this on a planetary scale, we could maybe one day have some real plants.
Yeah, well...
Well, they are real plants, but you know what I mean.
I would...
Potatoes.
Okay, so we want potatoes, but that's going to take a few generations.
We're talking thousands of years here. This isn't just a...
So, and the mosses and lichens will need to travel the 9 months to get there as well. So we're hoping they stay alive by the time we get there.
I mean, if we're shipping nitrogen from Titan, then I think we can keep mosses alive potentially.
And then... You've got to bring all your food because you're still not going to have food for a long time.
No. And the other thing is you're living off veggies. You're living off some leafy greens and a few potatoes. We don't have cows roaming around. We're all vegetarian at this stage. It's not looking very nice. That's probably the biggest cross for me personally.
No cows on Mars.
Forget the boiling eyes and stuff. If there's no meat, I'm not going.
Fair enough. Could you imagine sharing a rocket with a cow and a chicken and for 9 months?
And they'd be floating too.
They would.
They'd be floating. I don't think that would be enjoyable. These are really easy steps. Let's fast forward 2,000 years into the future and say we've managed to do all this.
Okay, have we abandoned Earth then?
I don't know.
Is this a choice? Do you kind of sign up?
Well, I think some people are thinking of this as a future proof. What happens if we really kill Earth?
Don't you think it's ironic that to actually be able to find another planet that you can live on, we have to do what we've done to Earth, which is why we have to leave Earth?
And wouldn't it just be easier to save Earth?
Well, you'd think so, but is it too far gone?
Well, that's a discussion for another podcast. But even if we got this far, this would only last a little bit. Everything we've done so far would disappear because we still don't have a magnetosphere. So those particles from the sun would strip away the nitrogen and the oxygen and all the lighter gases in the atmosphere. Once the atmosphere is gone, everything on the planet would die and we're back to square one. So we need to create a magnetosphere.
Okay.
Now, we can't kickstart the iron core, but what we can do is launch a giant metallic disc.
Sorry, what?
Yep. Yep.
How giant?
Well, we're talking pretty big and
How big?
not as big as the planet. It doesn't have to be that big.
Like a football field big? Or
Probably bigger than that. Let's think Large Hadron Collider big, like a few kilometres big.
Okay.
We're talking kilometres big.
And metallic.
It's a giant wedding ring, and it floats in space in between Mars and the Sun.
I imagine it's going to be iron.
Yep, it's got to conduct electricity, and from that we have a nuclear reactor attached naturally, and we pump a DC current through it. An electric current will create a magnetic field. If this magnetic field is big enough, it can just sit in between Mars and the Sun and orbit with Mars and protect our brand new atmosphere.
Well, let's get working on that. It's an investment for the future.
It is, but I did come across one method in which some people think we could do this in a couple hundred years potentially. And this one I found kind of cool, and it involves resetting Mars to kind of primordial Earth conditions.
Okay. Primordial Earth, what does that mean?
We're talking before life on Earth began, really early Earth conditions. So if we could send up huge lasers to orbit Mars and melt the entire surface of Mars, then we will melt all the water on Mars, all the CO2. You will create huge clouds of CO2 and an atmosphere very quickly. We would still need to import nitrogen because, we've got large lasers. We can do that easily now.
So the lasers stay there permanently?
Oh, they're just melting Mars.
All the time?
Yep.
Okay. And so essentially, actually, if it got too bad, you could turn them off?
I would hope so.
Okay.
Otherwise, living there might get a bit too warm.
Yeah.
So let's just say we can melt the surface of Mars. We kickstart the atmosphere. You could then import nitrogen.
Does this negate the need for the massive ring?
No, we still need that ring. So let's put a little asterisk in our text there. Say build massive ring.
Okay. Then get laser.
Yeah. But it will drastically speed up how quickly we can get an atmosphere.
Is it possible to build a laser like this?
We're getting so far out into sci-fi territory, it's getting absurd.
Yeah.
But if we let the planet cool a bit, then we could go on with kickstarting our 3 cycles that we needed.
Yeah.
And some people think this might only take a few hundred years. One of the cooler aspects of this is the people who believe in this plan think we could get phytoplankton in the liquid waters pretty quick. Phytoplankton are little organisms that photosynthesize. And before you start anything on land, you'd get all the life in the ocean going first, kind of like how life started on Earth.
Yeah.
And then we can move on to the toxic soil when we're all a bit better.
Presuming that those toxins don't actually leach into the fresh water and...
We're assuming a lot of things.
Okay, well,
assuming there's a giant wedding ring in the sky
let the truth
that
get
protects
in the way
the entire planet
of a good
too.
Story, yeah.
But to close this up, this whole idea of going to Mars is pretty absurd. Like, it is outlandish. There is no conditions in the foreseeable future which would even be remotely nice for humans to live in.
Yeah, and then it's interesting that there are investments from universities. NASA, for example, like I was there in 2019 at the Kennedy Space Center.
Naturally.
And they have... people looking at growing plants on Mars. So the wavelengths of light that they would need, the conditions that they would need, that's a lot of money and investment in education. And I guess there's some sort of way of actually, or you could, with biotech, transform plants to be able to survive in these conditions. And then you need to grow enough of them and stabilize the plant, and then you could take it. I guess that's the idea. So there must be people that think that this is doable.
Well,
Am I missing something?
I think it comes down to the science is a human endeavour thing again.
Okay.
It's like when Kennedy made his famous speech and said, we're going to the moon, and everyone cheered. People want to do these amazing things. And let's say, hypothetically, we never went to Mars, we never set up a base and we never terraformed Mars, but through the endeavour of trying to get there, we invented a way to keep plants alive under hostile conditions on Earth. We invented ways to recycle things on Earth better.
So how would you bring this to the classroom?
Well, initially I was just thinking from a pure physics point of view, but when I started researching it, you've got your 3 cycles. Like, you can teach your 3 carbon, nitrogen, water cycle. Imagine if you just set up an inquiry unit for kids. How could you terraform Mars? And through that, they would have to learn about how these cycles work on Earth and how these cycles are a fundamental thing for life to exist on Earth. So I thought that was fascinating. The conditions that are required to get to Mars and all the technology, the magnetosphere, the iron core, you got your geology, you got your biology, you got a bit of physics.
Yeah, it covers everything. I think that the new curriculum actually has this embedded as a mission to Mars. And then obviously, you've got, as well as your phosphorus cycles that would be needed too. And then your radiation. You could unpack this.
Even your little cyanobacteria and phytoplankton.
Evolution.
Yeah. Well, I think it was thoroughly enjoyable and basically proved that Mars sucks.
Yeah, don't want to go. Thank you.
Staying here on
Earth. Good chat.
Good chat, Steph.